everybody. Welcome back. I'm so glad you're here. I know it's been a long time you've been waiting for this presentation to start, but I promise it'll be well worth it. We have a really exciting guest speaker tonight. Christy, how you feeling?
I'm ready. So excited.
Awesome. I see that we have quite a few here. Y'all been telling space jokes. I'm going to be writing these down because Christy, don't read them because I'll be asking you
I'm
maybe
copying it for
tomorrow.
next time.
All right. Well, without further ado, I want to introduce you guys to our amazing guest speaker. Make sure that while you're listening to her presentation, you are typing in the comments your questions for her because we'll be asking some of those after her presentation. Okay. So today I'm excited to introduce to you Dr. Evelyn Morales. She is an executive leader and a pioneer in computer technologies with over 30 years of extensive experience and roles within the public and private sectors. During her 27-year tenure at NASA's Johnson Space Center, Dr. Morales served as the chief principal engineer within the engineering division, leading a highly technical, visible, and critical astronaut training facility, supporting R&D for operations in space. Her computer acumen and vision helped to advance human space exploration by developing state of the art flight software and hardware systems, with the purpose to prepare astronauts to perform dangerous excursions in microgravity. She led in the development of innovative immersive graphical applications that successfully supported every space shuttle and International Space Station mission since the year 2000, as well as helping to establish the Commercial Crew Program in 2011. Dr. Morales co-wrote the state-of-the-art flight software, Dynamic Onboard Ubiquitous Graphics, or DUG, the first virtual reality training tool used to prepare astronauts for spaceflight. Currently, Dr. Morales serves as a business associate for Aegis Aerospace Inc., a defense and space manufacturing company. Wow. Okay, I'm going to bring you on, Dr. Morales. Welcome to Space Teams.
Well, thank you, and good evening.
Yes.
Yeah, well, it's an honor to be invited to talk to all of you this evening. Sorry for the delay. There is always a technical difficulty somewhere, but I'm so excited to be here and to talk to you and share a little bit of the history of VR and tell you about the multiple applications of this incredible technology for space training and operations. So thank you again for the invitation. And so,
So great. Well, I'm going to go ahead and share your screen, doing that right now, and you can go ahead and start your presentation.
okay.
Go ahead.
Okay, well, thank you. So my presentation is titled Using Virtual Reality, VR, to Simulate Missions and Train Astronauts for Space Operations. So let's begin with to ask you and see how you can look in the history of VR for those that are involved in this technology at some level, and let you know if you think VR, virtual reality, has evolved very quickly. If you look at the history and the timing and everything that has happened between 1999 and 2000 and 2002, actually, it's almost here. You can see through these images that really the technology doesn't seem to be evolving very quickly. But internally, VR has really advanced in the system that actually supports virtuality or immersive technology. And we're going to talk about that. We're going to go into it deep into understanding what the system has and what it uses. So the technology really has not gone as far as we think of it. And part of that is because of the content. Now, virtual reality is really the perception of being physically present in a non-physical world. And with that said, is basically being immersed in a what is a world that is synthetic. So virtual reality, as you see me here in this picture in particular, can be used to immerse us into worlds that cannot be simulated any other way. So, and that's the beauty of the technology. So if we look back in the history, and this is important to understand because it's good to know where we were, where we are going, and everything in between, and how can the future be. So you can see in these pictures, if you look at the helmets in particular, they haven't changed that much, or it doesn't seem that way, right? It's just covering your eyes, almost the same size, but internally, a lot of the system and the optics have really, let's say, changed. But and that's what has made immersiveness so much powerful in these days. So if we look back, when I started actually in 1992 working at NASA, the first assignment that I have, it was here in 1992, it was to help astronauts to build a system that can help them repair the Hubble Space Telescope, which it was sent to space through the space shuttle in 1995. And as you see through the pictures, and we get down to 2020, you can see all the kind of interactions, right? And the different settings that we have to use to support that virtuality over time. So the head-mounted displays is one of the components of the virtual reality system, let's put it that way, is the VR helmet, has gone also through a lot of changes. In the beginning, you see in the 60s, the helmets were extremely expensive. And as you see, you go towards the right, you see that the helmets are now commercial. They're very inexpensive. They're in the 300, 500 mark. So it's very easy now for people to utilize and to have it, to buy them. But again, remember that the VR system is more complicated than this. This is just the external, the way that you see the world. Now, again, like I told you before, virtual reality was used the first time for space training in 1993, when we helped to repair the Hubble Space Telescope using this technology. We actually trained the astronauts, and the astronauts got very involved, giving us input into how better to develop this system. So it wasn't something that our engineers or our team built by ourselves. We actually had to interact a lot with the client. And this is something important as you're building your content and your solutions. You need to talk to who is the client, who are you doing this for, and who is going to be using it as well. So here you see a very two memorable pictures, actually. One is a synthetic view of the Hubble Space Telescope on the space shuttle, on the space shuttle bay. And then the other picture is a real picture from one of the astronauts. Now, the biggest need to develop virtual reality and do R&D, research and development, was to really support astronauts to do the spacewalks and spacewalk training, obviously, to execute the spacewalk, but actually to train them. So that needed, obviously, that human immersion that was so important in order for the astronaut to capture and understand what the task will be like. So here you see, I'm helping here one of the astronauts to get into the helmet and get into the system so that he can see himself in outside the space vehicle. In this case, it was the space station. So this was extremely unique environment that there isn't any other way to replicate. And again, if you look in the future, right, we're going to be able to use this technology for so many other applications in terms of being on the moon or developing something for Mars. So anything can be possible here. So one of the important points also in user virtuality, it was also the constraints, if you will, of the facilities that we use. And at that, I mean, we still use the water pool, as you see it here, is a waterwayless environment where NASA uses to actually train astronauts as well. But this environment has a limitation, and you'll see it very shortly. We'll talk about how when you're underwater, you have other issues with the dragging of the water and the simulation internally. That training is not necessarily all positive, because there are many issues in terms of the environment. It's not a real environment. You're not actually in a space. And you actually, for you, it's very difficult to visualize what the environment, what you're looking at, and visualize what the task will be very easily. So the water has, the water wayless environment facility had a couple of issues that we have to deal with. Then the other place where astronauts used to, or we used to train astronauts, is also with mock-ups. We will build, for example, in this case, a piece of equipment, and then we'll set it up in a way where they can manipulate it. But all of it, even the water, is extremely expensive. It's very costly, difficult to reconfigure, and there's a lot of constraints. So we created the virtuality, right? So VR came into place to really merge all these training facilities and provide this new fascinating visual environment where anybody can immerse themselves and basically execute any different task, whatever we set it up to be. So in here you have the picture of a real of the space station. It's a synthetic, and it has a lot of detail, meaning that we built it in 3D graphics. And many parts of this station, like anything else that we built, can be manipulated in 3D, in a 3D environment from within this system. So it makes it extremely powerful. Now, the VR immersion has really transformed human spaceflight. And when we started in 1982, it was really, that was actually my job as a young engineer. We needed to, at that time, if some of you can look back in 1992, we were basically at the end of the space shuttle program, or coming into the middle of the space shuttle program, but we were starting to build the space station. And the big question that we had, one of the big questions, or one of the issues that we had, is that we were going to be doing a lot of spacewalks and operations outside vehicles. So we needed to be able to very quickly train many missions and train astronauts into many missions through the year. And that brought us this team, a small team, to concentrate in building this technology as a full system. So it's not only, the virtuality of using helmets, but also everything else, all the components that makes the whole system. So this immersive technology obviously helps in visualization, helps with the improving processes, reconfiguration, reduces cost, which is very important. It has infinite applications and contents that we can build, and also really have improved collaboration. If you see here, this is the visualization part, right? We have two astronauts. This is just examples where the astronauts are immersed in the environment, and they can actually see themselves in the environment. They can fly around, etc. They can manipulate different structures from there, and it gives them a lot of spatial awareness, where they are in relation. And that way, when they actually execute the task, they know where they are in relation to other things or other parts in space. The improving of the process was very, very important, because now we were able, in something that you need to look at as you're building any solution at any point, and we will, because we're building, Artemis and all these new projects going to the moon and Mars, is that including virtual reality and immersive technology through the process actually makes all the design, testing, training, and operation and maintenance also a one deal, a one environment deal, meaning that you can use the same environment with the same data that you started with in the design and the testing. You can utilize it up to the maintenance when it's time for maintenance. So it's very, very streamlined. It really helps in the process of the data that has been produced for the specific task. Now, as I said before, reconfiguration time. This really, VR really made us to reconfigure missions very quickly. And we had to support between 4 to 7 missions a year when we were building the space station. And that means that we have to very quickly set up different components in different places around the space station. So reconfiguration was very important. So imagine if you have to do this in a real mock-up. It's very, very time consuming, expensive. Also, imagine if you have to do this underwater. You probably wouldn't be able to see the whole space station. Just the same thing as how are you going to be simulating being on Mars if you have to go underwater and train underwater? So if you can see all this, you know, how VR is such an amazing platform and system to do this is obviously invaluable. So reconfiguration is a big, big part of VR. Reducing costs, I don't have to say much. When I started, the systems that we were using for virtual reality were in the millions. We have servers that were very costly. Maintenance was $500,000. To today's cost, we can do probably the same thing, same application, same speed in a space for maybe 50K. So the cost has been incredible. We have reduced cost in a very exponential way. Infinite content. Well, I cannot tell you that using VR, you can basically build anything you want to. I mean, you can build, a lander to the moon. You can build a gateway. You can build anything on Mars. You can, go to an asteroid and destroy it. You basically can do any content you want, just like a video game. Collaboration. Why is this so important? Because now we're moving in a very global way. We talk to people all over the world, and it is fascinating when we can actually immersively, we can collocate ourselves in that position, in particular in a space, and being able to invite somebody that is in Germany or is in another location in the world. So the collaboration is really, really important. We can also, having this virtually in a digital format, let's put it that way, we can also share content and information when possible. So this is also a very important part of VR and the positive things that VR brings to us. So another part that I always talk about using VR technology, and we're just going to touch very briefly, is about when we are and at what moment in time that technology, particular technology, in this case, we're talking about VR, is best to use. Many people early on, when VR was still kind of growing and people didn't know how to integrate the different systems and components, it was a little more, it took a little more work. That was when the system and the technology was kind of in the growing. But as it gets to the maturity level, which is we kind of obtained that in 2010, 12, I will say that, is when we realized, we have a very mature, stable system. And I think we could endeavor now into maybe integrating new components, doing other things, expanding the content, et cetera, et cetera. So also, we were able to set the system in a desktop environment where it was portable. So we became it was mature enough so that we can do other things with the system, and so this is important to know, because VR, I think, is in that maturity level. It's kind of in the beginning of the maturity. There is still more to grow, but it's pretty stable. So now people can do very and build incredible solutions with it. So to go back to also when I talked to you about the graphic engines and, well, not the graphic engines, the helmets, I wanted to emphasize about the complexity of a VR system. So when we talk about immersive VR, we not only talk about the helmets, but we need to talk about the whole system. And that system is composed of graphic engines. A graphic engine, whatever that's being used, is what displays the graphics in the computer, right? You have an IO device that will be the helmet, that will be whatever hardware you use for pointing, for IO, for manipulating with your hands. Also, you have simulations, which are mathematical simulations of the items and the components that you have in that graphical environment that you want them to behave in a certain way. And then the data, which obviously is the full-blown content, meaning what are you representing? The whole station, that will be your data and content. So that all these components is what makes the system work. So every one of them you can update, and they could continue to evolve, obviously, over time. Now, as I talk to you, graphic engines there are several, there are many. We have used the commercial one. As you see, Unity and Unreal are very well known, and they're out there. At NASA, in 1992, when we started building the system, there wasn't any really graphic engines that we can use. So we had to find a way to build our own. We took a lot of programming. It took a lot of programming time, and we built our own graphic engine for the purpose of helping NASA train astronauts for the spacewalks. And that's what we decided, and we built the dynamic onboard ubiquitous graphics dog in order to accomplish that goal. And it's still being used to today, because it has many components and interfaces that other graphic engines don't have, specifically for space training. So Dog has been extremely powerful, and it took many years to develop to the point where it's a portable system, and it was sent to space at some point with the space shuttle, and it was also sent to the space station so that the astronauts can run the software as well, and run different scenarios if they needed to, for retraining and for spatial awareness as well. Now, the biggest actually use of the virtuality in VR has been for the extravehicular activities, which is called spacewalks. And you see here the representation of some of that, where we have the individual, in this case, because these are not astronauts, and they're looking at the environment and seeing the different details. In one, they're flying the Safer, which is a rescue backpack that the astronauts use in order to fly back to the point of where they left the structure. That way they can save themselves. So this whole scenario has been very, very impactful and critical for definitely building the space station, because of the many, many spacewalks that we have to perform in order to build all execute all the different tasks that we needed to build the station. So if we compare that again, and this is important because I want you to see the differences with working underwater and having this physical event where you have the spacesuit and all that, which is great, because when you're underwater, you're really testing the suit, the communication, and many other things. But you can tell that you don't have the view of the space as you will do if you go out of space for real. And the dragging of the water is there, so you have gravity. So it's really an environment that has some, I wouldn't say not so much positive training, but obviously as I mentioned before, being in a spacesuit, communication, being able to, for example, walk, do the walking, doing the touching of the handrails, all that is great with the spacesuit. But other than that, the visuality, the visualization of it is not there. So if we look at our human sensory system, and this is important to kind of know, right? Our system, our sensories are the sight, which is the vision, the hearing, the smell, taste, touch, vestibular, which tell us about the movement, and the proprioception, which is the body position. All these are important. But the most important one, the most significant, is the visual. If you can see what you can see, you will never forget. So when we have a VR system in comparison, for example, to a water pool environment training, you can see now what the differences are in which sensories you're using. And the senses are very important. So when we're using the virtual reality environment, we're concentrating in the visual, and you're seeing it, and that's extremely impactful. Also, you have your positioning system. I mean, now you know where you're going to be in relation to other objects in that space. So imagine you're building, for example, a lunar lander. As I said before, you have somebody walking around, or maybe a mock-up or some module, and you're flying inside a module, and you're building it. So all these perceptions and these sensories are very well related to VR. VR will give you that visual that nothing else will give you. If you're underwater, your biggest sensory will be the touch, the tactile, and the vestibular. So you kind of can tilt and know your movement in one space, and that kind of give you the sense of floating, but still it's not enough. So when you merge these two facilities, if you will, or these two type of training, then you get something very powerful. And that was always the idea that we have as we were building the solution for this system. It was that we were always in coordination, collaboration with people that were doing the training underwater, and how to best provide them with the environment through the VR system that will merge with what they see underwater. So a lot had to do with, the trainings and the astronauts that have to come and do all this and kind of put all this together in a way. But definitely the visuals is something that is extremely powerful. So again, like I say, we can build simulations like building something that we can use like a hotel in the LEO orbit, low Earth orbit. We can build anything, any kind of structure in VR and test it and, simulate that we're there. I used this, for example, this was a mock-up, a simulation of a exercise machine and how the machine will work inside the a crew module, Orion, and how best could be placed and give it the space with the astronaut moving and all that stuff, measurement, etc. So all this can be very easily done using virtuality. Another environment that we had that NASA built was this Argos, which is an offload environment where you have, like you see there, an astronaut or that can be offload, and it can simulate like they're actually in outer space, right, floating. But again, the environment has limitations because of the movement. You still feel that you're being pulled, so it's not really floating. But if we combine this with VR, and then we put a helmet that is wireless, then now we might have something very powerful, because then you are also adding the visual, which, what I said before, is the most powerful sense that we have. And as you add that virtuality, and then in this example, you also add the touch in some kind of movement, then you also have the potential of a great training environment. Again, like the water, it has its limitations. But this will be something that is kind of similar to the water in terms of the what it provides. So the other part that I wanted to talk today also is about the when we build VR systems. Many times we have to build specific components, details. They have to be easily are easily. We have to build it in a way that can articulate in the way that we want it. But that's if we build every component, but sometimes that's not possible. For example, in this environment, we wanted to have a shot of the inside of the space station, and to build every component there in a 3D, as a 3D component graphical is very difficult. So you can actually use photographic content also to represent a piece of that equipment and make it look like it's real. So this is something that has been used a lot for different components and different parts of the system. So not every component in your system have to be physical or in 3D form. It could be also photographic, which means it has just a 2D value, not a 3D value. VR has also been used a lot for kind of some type of physiology, connotative and brain function training and tests. And this is something that is still being used for human factors and medicine. So VR has really been extended to those, to support those kind of applications from different groups. So there is a lot of potential here, as it's kind of evolving a lot. So as I said before, VR can really be used to maintain brain and vestibular fitness during long duration flights. And this is something that has been tested, and it still needs a lot more research, but there is a lot of potential to do that. Imagine when we're going for long duration flight to the moon and to Mars, then this would be fantastic to have a system that can be easily power on and can give the astronauts a way to retrain themselves and get some extra fitness in that area, mentally and visually. So if we put it all together now, we can say that VR provides a control and repeatable way of replicating that scenario for spatial awareness. We can really explore any place in the world, anything that we want, that we can create. We can do it through immersive technology. And I keep going back and forth between immersive, because VR is a fully immersion. And when we talk about augmented reality, is an augmentation of the real world with something synthetics, which is a completely different technology. But sometimes people mix it. But when we talk about VR, we talk a completely immersed system. You are immersed in that synthetic environment. So VR has access to resources that will be prohibited otherwise and expensive. Again, like I showed you before, you don't need a water pool to train. You don't need a expensive mock-up. Now you can just simulate your way into a game, a VR game, to train for space. VR also provide very innovative ways to visualize, manipulate data, because, I mean, think about it. We can manipulate any data through simulation and data and mathematical simulations, and represent any kind of data. Could be even financial data or anything that we want to, that is out of not necessarily space related. So this is obviously a huge place to research. Now, here is just different representations from different sources about the possibilities of VR and all that it can do. It's just so much, and it's becoming so much real because of the graphics and the resolution and of the graphics and the power of the streaming now. One of my really dreams would be to stream real time when we land on the moon, stream that data so that we on the Earth can visualize what the astronauts are actually doing using a VR helmet. So we can basically be stepping on the moon with an astronaut. That will be probably one of my dreams, but it's something that I talked a lot about it when I was at NASA. So training and operations CVR. Again, like I mentioned, we used it for spacewalks activity. We have used it for Simplify Aid and EVA rescue, which is the safer backpack that the astronauts use to rescue themselves if they get detached from the space vehicle. We use it for robotics operation, very important. Any robotic arm and anything that can be manipulated like that could be was represented. Zero G mass handling, we were able to actually, with a robot connected with the VR system, we could actually simulate moving a mass that has some weight in zero G. And that's something a little bit more involved. I'm not going to touch into that because that's an extended system byproduct of VR, of the VR system. And then procedure development and review. That was something that we did a lot using VR. We had to work a lot with the trainers in order to build the different components for this particular mission. So that's VR can be used for all this. Robotics operation, like I told you before, this is a scenario of an actual robotic operation activity with actual astronauts and a trainer. You see in the back an astronaut on the helmet, under the helmet. He's looking outside the space station. And then you have another astronaut actually manipulating the robotic arm. And that's all in conjunction. So whatever she moves, the other astronaut move, the second, individual astronaut that is in that system can see. So we're all sharing that space. We have the Simplify Aid for EVA rescue. You saw it before. We also have the Zero G mass handling training. So this is very powerful because, manipulating something in a space, it gets a little tricky. If you do that training underwater, then you also have the dragging, and there is other issues that can come from that, difficult to reconfigure very easily. So it's very easy to just reconfigure mass handling under a VR system because we can basically use any form and any visuals at any location. So it's very easy to do. Not easy, but it's more feasible and less time consuming. Procedure and development was something that was huge. We took it for granted, but we had many times when we've spent many hours with astronauts in the loop, going through different scenarios of how, for example, a robotic arm will move and how will be manipulated over some time to do certain tasks. And that can take hours and hours to define and to come up with a final plan. Through all that process, you can use virtual reality to really see and test and come back and forth from that scenario. So it was very helpful to have this in our facility. We also were able to send in 2018, before I actually departed NASA, we were able to send to space an onboard VR trainer. Basically, it was a laptop with the full-blown system where the astronauts could get on and train for their particular task, and they can use it on the space station on the fly. So in the future, if we have a hotel in LEO orbit, if we have a settlement on the moon, we can actually use VR for many tasks that they can train on the fly in there. So that's gonna become extremely useful. Now, there's a lot of lessons learned as I'm coming into the end of my presentation, but there is a lot of lessons learned that I have building this system and helping to build. And I have to say, granted, that our team was composed of about 5 engineers. That was in average. So that was very important because you always need good, capable individuals with the skills necessary to actually build this system. So my lessons learned were to being able to identify the problem. So the problem that we had was that we needed to do a lot of spacewalks and we didn't have enough time to do it. And it was going to get very complex building the space station. So NASA commanded us to build the system to being able to support this training over time, over the 17 years that took us to build the station. So also being able to understand the problem. So whenever you're ready to build this system, you have to know what the problem is that you're trying to solve and understand it. You have to have the skills. So your team have to really educate themselves and have the skill to be very agile and have wear different hats within that system and know what's going on in different areas. With our team, everybody has their specialty, but even like that, we all kind of knew what everybody was doing, and we were able to communicate also that and apply our skills. We need to be very analytical with this building these scenarios because it's time consuming and has a lot of details. Attention to detail, obviously, just because of the type of depending of the type of training or what you're using it for. You got to be very flexible to maybe incorporate other pieces or incorporate maybe a new helmet or incorporate a new programming components. So you have to be able to set up the system in a way that you can always update. You also have to be very involved with what you're doing because I think this is very time consuming. It's time consuming, so you really need to be very involved in what you're doing. So you have to be able to work as a team player, and this again goes with the skills necessary. You have to be able to talk a lot about what's happening because it can get very complex. So now, this is a shot that I wanted to add at the end of our first virtual reality system that we sent to space for a spacewalk. And as you can see, we didn't have a helmet ready for certification to send to space, a VR helmet. So we have to build the optics using a laptop. And this system was called the laptop on the head. And from that was the beginning of sending really VR to space. And then we perfected it or made it better through time until the last one, which we sent in 2018. So this is just a piece of history here. So now I probably going to open for Q&As. And I think that's the end of my presentation. Hopefully I went through it. Sorry for the wait.
Oh, that was great. Thank you so much. I'm going to remove your screen so it's no longer being shared. That was fascinating, and your lessons learned was perfect for our participants for space teams because I think a lot of those lessons are lessons they need for this week, especially with the teamwork.
Thank you. Yes.
Well, thank you so much. We have a few questions to ask you, some that were submitted earlier and then some that we were getting in the comments. Christy, do we have a question from what was submitted from earlier today?
Yes, let's do one from Olivia. She wants to know, what was your first project?
Oh, my first project. Oh, this is exciting because my first assignment was actually to build a simulation for a lunar lander.
Oh.
So I was building the whole scenario, I was using some mathematical simulations. So imagine then I thought, okay, we're going to the moon. And 27 years after, now we're probably going, but I waited for a long time. I think that was my dream that we were going to go back to the moon. But at that time, when I started, we were building, supporting the space shuttle. So that kind of, took another turn, and I started working more in the space shuttle and the space station.
Great. It's an amazing start.
Yeah, you were just ahead of the game by
Right.
about a few years. Okay, well, from the comments we have, how did you know that you wanted to do this as a job?
Well, that's Actually, and I love programming. I love graphic computing. That's my life. I think I guess let's put it this way. My passion early on when I was young, I was very visual. I love graphics and I love art. I wanted to be an architect. I ended up building the space station graphic. So if you can start seeing I always gravitated towards graphical and all that stuff. Now, when I got into the university and I started doing a little bit of computer graphic for art, I realized, wow, this is very powerful. And I really got involved into programming. And that got me to my second degree in computer science. And I loved it. I could put together my artistic side and my computer side. And when I saw that I could basically what is a type, right? And do commands and have something built, make something, create something in my computer. That was like fascinating to me. So that's how I got into it. It really was my passion for the graphics and then the computer programming side. And I was selected because they needed at that time precisely a team that could build this kind of system for space training.
Perfect. Well, one more from the comments. What kind of problems have you not solved yet, more specifically in the field of robotics?
Well, in the fields, well, robotics has a lot of still issues, right? I mean, that's probably I wouldn't concentrate so much in the parts of robotics, but in the parts of VR, which is what I was talking more than anything. And I think that I think still the one of the parts that is still in development is being able to have a wireless helmet. Having a helmet, for example, when you're visualizing your content, is still cumbersome. So it has to be something that is completely wireless, and you have to have the power on that helmet to do the visualization. That's something that is still kind of in development. We still need to be tethered at some level. So tether meaning connected. Now, in terms of the robotics, there's many things that there's still the robotic. I mean, that's kind of a very long answer, so I'm not going to get into that necessarily. But yeah, in the part of VR, I think that's the thing that I can say towards the future enhancement for VR.
Interesting that it's not a computer or software related issue. So
no, I mean, software. No, we can do anything with software.
Do anything.
Well, right, and AI can do a lot too.
True. Well, following up on that, Jackie asked if you had the budget, what would you like to build?
Ooh, if I had the budget, oh wow. I will build a fully, I mean, if I have the budget, and maybe I will, who knows, right? I mean, I want to build a whole, basically, environment on the moon. I want to create a whole like a metaverse in the moon. I mean, I want to create really how will be to live on the moon and all the components that could bring, and how people will mobilize and move around. How are we going to be mining? Are we going to be taking things from the moon surface? How are we going to be moving around? I will build all that logistic if I could, if I had because I think that's next. We already have been on the low Earth orbit. We have been there, and we can build many things there, like a hotel. But I wanted to be on the moon, so I will probably build that if I had the budget.
Well, great. Maybe next time we have you on, you will have done that. Well, one last question. We so appreciate all that you have shared tonight. Do you have any advice for our participants who are in space teams this week working on this spacecraft challenge?
Oh, well, I mean, that this is what a great opportunity you have to work in this incredible space challenge. I mean, nothing that I have worked in my life is so rewarding as to work in a space or space related themes. Having the opportunity to work with a team to build something unique that nobody else has built. I mean, that's the beauty. So I will say enjoy it, be very creative, think out of the box, And don't look at what somebody else is doing. Just think of what can be done, within yourself.
Oh, I love that. What a great way to end. Well, thank you so much, Dr. Morales, for joining us. And good luck, everybody else. We will see you tomorrow.
Thank you. Thank you. Sorry for the delay. Bye-bye.